So as your last task on this page, we're just going to solve for x in each of these problems. And just like we did in question number 4, I suggest we look at the exponential part, not the log part, because the log is still sort of new and foreign to us, and it's probably still not clear why we would ever find that useful. And I'm going to ignore it for now so that we can focus on what our brain is already pretty used to. We're used to seeing exponents, and we can do exponents pretty naturally. Now I just realized, sort of subconsciously, and some of you might have caught this in the previous video, I had naturally just filled in what that x should have been because I probably didn't even think about it and realized 2 to the power of 2 is 4. So when I wrote that blue spot, I wrote a 4 without even realizing I did it. Sorry about that. And hopefully you can see why I did, because that is the solution for x. X is just 2 to the power of 2, and we know that 2 to the power of 2 is 4. So if you've kind of found yourself naturally just filling in whatever x is as you go, that's completely okay. You're welcome to do that, because ultimately that's where we're going to head with this anyway. We want to get to the point where we can look at a log expression and immediately figure out what x is just by using the exponents we already know and love. So in letter B, let's think about the same thing. It says x to the power of 3 is 27. Let's think about that. That's something to the power of 3. So something times itself 3 times. That would give us 27 as an answer. And what could we use? 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. You can think about all sorts of possibilities, but 3 times 3 times 3 would do the trick. So x must be 3. In letter C, it's kind of the same idea. 5 to the power of x equals 125. Well, that means 5 times 5, however many times, would give us 125. So let's think about how many multiplications we would need. 5 times 5 is 25, too small. So if I multiply another 5, that's 125. Yep, okay. So I needed 3 of them. That means x must be 3. So again, just basic exponents, nothing too crazy. In letter D, we have 6 to the power of 1 equals x. Well, that one's already kind of nice, because 6 to the power of 1, we already know that. 6 to the power of 1 is just 6. That's like saying I have 6 multiplying itself once, so that's just 6. There's nothing else to do. So hopefully as you're tying these ideas together, you can really take away from this lesson one major idea, and that's that an exponential and a log are opposites of each other. And once we understand how their pieces kind of fit together, that's the biggest thing that we can walk away with understanding, is just understanding that the log is the opposite of the exponential, and vice versa, that the exponential is the opposite of a log. Going back to question number 1, where we sort of introduced this in the first place, we talked about how well we understand these exponential problems, these geometric problems. Now we understand them in a very literal way, both forwards and backwards. Logs are going to be the opposites of exponentials. And as you probably know, algebra is all about opposites. Adding is the opposite of subtracting. Multiplying is the opposite of dividing. Square is the opposite of square root. So now we essentially know another pair of opposites. Log is the opposite of exponential. The entire rest of the series of lessons in this chapter, so next week and beyond, is meant to help you better get familiar with logs. So if you don't feel super comfortable with it yet, don't worry. We have lots more opportunities built in to try to get more familiar with this log idea. Because it is weird at first. It's a word. It looks different than most of the other expressions and things we've used in algebra. But don't panic about that. For now, just try to get comfortable with the idea that a log is simply an opposite. Just like a square root is an opposite of a square. And an add is the opposite of a subtract. Log is going to be the opposite of an exponential. If you can hang on to that idea, then in the next series of lessons next week, hopefully we can build on that foundation.